Nicholas has been working at worked for Yahoo as an architect in JavaScript for a long, long time. He blogs online at nczonline.net. He wrote a couple books, including the O'Reilly book, High Performance JavaScript. He wrote a chapter of Use Faster Websites as well, right? I think in this book.
Yep.
Yeah. So he's well-traveled, well-regarded, and I think it should be a great talk. So I'll turn it over to him. I think it's all set.
Yeah, we'll see how it goes. Oh, so how's everybody doing?
Very good.
Good. So I saw on the way in here, I don't know if you guys did, the little sign said maximum occupancy. 49 people.
Per room.
Per room.
Under the rules. This is 2 rooms.
Yeah. Is that for the benefit of me or the fire inspector? I don't know, I think we have more than that. Who wants to add up 49 twice? How much is that? This is what professionals do when they stall. Okay, that should be good to go. Yeah. Hi, everyone. I hope you had the pizza. Oh, I wanted to ask, who went and ate some of the gluten-free pizza?
No.
Well, it's always fun because I can usually tell just by looking around because people go and so I'm allergic to wheat, so I have to have gluten-free pizza. And anybody who is not allergic to wheat that tries the gluten-free pizza, the first reaction is like, there's something wrong with that. Like it's just not quite right. So somebody in here had that experience. And I'm glad for it, actually, because now you know what I go through. It's not the same. I said, sorry, I'm going to digress a little bit. Because I know that I've been allergic to wheat for like 10 years. And so I eat a lot of like gluten-free stuff. Right? And it never quite tastes the same. So whenever it says gluten-free whatever, I always just replace gluten-free with not. And it gives me a better idea about what to expect. Right? So it's gluten-free pizza, it's not pizza. Set expectations appropriately. Yeah, I'm a little punchy. Sorry. So Jonathan was saying a little bit about me. I did work at Yahoo for about 5 years. I was a lead over there on several teams. I'm a co-creator of CSSLint.net, which is a CSS code quality tool, and a contributor to YUI, and wrote a bunch of books, which you see down there at the bottom. If you're enjoying this presentation and you want to tweet about it, my Twitter name is Slicknet. If you're not enjoying it, then my Twitter name is Brendan Ike. So Brendan's actually from Massachusetts, as am I. I grew up here. I was here for I don't know, around 27 years before I moved out to California to go and work for Yahoo. And I miss it. Glad to be back. So like one of the, I think it's like the second or third time I've actually given a talk in this area, which is pretty cool. Very happy to be here. And you know, California is kind of okay, but I've always kind of considered this to be my home. Just because I kind of relate to people here, we all have our sports things. So in California, if you say wicked, it means this, as opposed to the proper Bostonian understanding, right? Way, way better. So this is my cube, actually, at Yahoo. Before I left. It's a very subtle homage to my hometown sports team. So there's the Red Sox championship t-shirt, and then this sign went up after the Celtics won the championship a couple of years ago as I was waiting for the t-shirt to come in. And yeah, it's very interesting because like in California there's not really a regional identity because everybody who is there is from somewhere else. And so you know, around here, like you could walk outside right now. Any one of you could walk outside right now to anybody that's passing by and be like, hey, how about the socks? And they would turn to you and go, I know! Right? Because that's just what we like all have going on here. Right? And if somebody from out of town comes in and says they're going to, you know, their team's way better, we're going to stand up for our team, even if we think they're kind of crappy. Right? So it was like out in California when the Celtics and the Lakers got to the finals, there was a guy at work who was a Lakers fan. And I was like, hey, we're going to kick your ass. And he goes, oh yeah? You're probably right. Like, no, stand up for your team. But they got back at me a couple of years later. They filed my lawsuit. It's very upsetting. Yeah, so California weather's a little bit different. People in California don't know what this is. That's like in the front seat of my car when I first moved out there, I was giving a friend a ride. What the hell is this? What do you mean? It's because like bad weather in California is a different thing. And bad weather in California means if you go outside, you might get wet. Right? And then Massachusetts, like go outside, you might die. It's really bad weather. And it's funny because I was talking with a friend, so we don't really realize Massachusetts how much we talk about the weather, right? So you go outside, and then you come inside to like a restaurant or something, first thing somebody says to you is, hey, is it cold enough for you? Opposite during the summer, right? Is it warm enough for you? Love it, it's great. And last story, I promise, I'll get to something more interesting. I was walking with some friends in San Francisco. It was a really nice day in September. Right? And this woman says, man, it's such a nice day out. Right? Late September. And you guys know the proper Bostonian response to that?
Wait 5 minutes.
Yeah, we're not going to get many more of these. Right? And I stopped myself because they won't get that. Anyways, we can talk about JavaScript now. So I'm going to talk about JavaScript performance, and I like to start out with the question that I usually get asked at the end, which is, does JavaScript performance matter? So JavaScript is slow, or at least it used to be back in like IE6 Netscape days, very slow. And then all of a sudden Google Chrome was released, and wow, now JavaScript is fast, right? Much faster. And all the browsers that we have now have these optimizing JavaScript engines. They're doing just-in-time compiling and all kinds of weird sorts of stuff to make JavaScript run fast. And so we've seen some pretty remarkable speed improvements over the past couple of years. And so this graph is of the WebKit SunSpider JavaScript benchmark. This is taken from the IE9 website. So a lower number is better. Right, we have IE8 all the way on the left, IE9 all the way on the right. And so you can see it's just like an order of magnitude of improvement from IE8 to like Firefox 3, and it just keeps getting better as we go along. And so I've heard a lot of people say, well, we don't have to worry about JavaScript performance anymore, right? The engine's doing it for us now. Actually, don't need to worry about that ourselves. And I always say this, well, remember computers like 20 years ago? Like they were kind of underpowered, really slow, and everything was slow. And you actually knew to wait, and that was okay because this box was doing something pretty incredible. And now we have these like super, super fast computers with tons of memory and like CPUs that 20 years ago people thought wouldn't have even existed. Right? Incredibly, incredibly powerful. And yet we still have slow applications. How many people have used a slow application this week? Yeah, that's not supposed to happen, right? Our computers are really fast. Well, what happens is, as programmers, we actually get less disciplined when we don't have to worry about those constraints. I mean, well, I'm not going to name software because it's something in the video game. But you guys know what I'm talking about. So out there that you like, run it up and all of a sudden you're like, 5 megs, really? How much memory do you need in order to like move some pixels around? It's just insane. It's because as programmers we become less disciplined. We think that everybody has the fastest CPU, the most RAM, the biggest hard disk, and that leads to a horrible user experience. And then something interesting recently happened. Right? We have all these mobile devices that now have web browsers on them. They also have JavaScript engines. So now JavaScript is like kind of slow again on those devices. So what I did here was took the SunSpider benchmark from a bunch of phones, a bunch of devices, and ran it, overlaid it on the desktop browser one that I showed you earlier. So you can see like the iPhone 4, right, worse than IE8 in terms of JavaScript performance. Right? Oh, but it's like the best thing ever. But it's slower than 98. Is it still the best thing ever?
Well,
Yes,
depends
because
what you
Apple
want.
made it, because it has to be the best thing ever. I want you to know that I got an iPhone only under severe duress. So it's not necessarily by choice. You can see that things are actually improving, but we're not anywhere near where we are, even at like Firefox 3.6. I haven't yet run it on the new iPhone. I'm sure it will be even closer, but we're just not quite there yet. So the bottom line is that it's still possible to write slow JavaScript, especially if you're not paying attention to what you're doing. And the reason that we care about this more than anything is because JavaScript affects the user experience directly. That's actually why we care. If it were just for geek cred, we'd be like, oh yeah, it runs faster, whatever, who cares? But the fact that you can negatively or positively affect the user experience is the reason that we care about JavaScript performance. Now, to understand a little bit about how JavaScript affects the user experience, I'm going to talk about a part of the browser called the UI thread. So all programs have a UI thread. That's basically the process that's in charge of drawing updates to the screen. So whenever you're interacting with something, right, you click on a button, you highlight something, the UI thread has to come in and update the UI so that it appears that you're actually doing something versus just random stuff popping up on the screen. So the browser UI thread is responsible for two things, actually. One is drawing the UI updates. The other is executing JavaScript. And it can only do one of those at a time. Now, because it can only do one of those at a time, it has to keep track of things as they come in, so it knows what to do next. Right? So there's a queue that as events occur, like I need a UI update, I need JavaScript to be executed, they get added into this queue. And the queue just keeps getting built up, and things are executed in the order in which they're added to the queue. So when you have a very simple example, like a button with an on click, there's a bunch of stuff that happens when you click that button. And so the first thing that happens is a UI event is scheduled to draw the button in the down state, and then your JavaScript event handler gets called. And then the UI update is scheduled to draw the button in the up state. Right? And we're just talking about a very simple example of this. Right? You just go and click a button, draw the down state, right? Slightly different, do your JavaScript, draw the up state. Apple iPhone, go away. All right, so to take a look at how this looks visually, if you consider this the UI thread at the top, and think about it like a pipeline or a timeline that's increasing in time from left to right, what happens when you click is basically get these jobs added into the UI queue. Now, I'm oversimplifying here because you know as well as I do that there are a bunch of JavaScript events that could possibly be triggered when you click. But there's not enough room on the slide to put them all, so we're just going to go with this. So when clicked, those get added in, and assuming that there's nothing else already happening in the UI thread, then the first UI update is going to happen. And that's going to draw the button in the down state. And then the on click is going to execute. And then the UI is going to get updated again to draw the button in the up state. And a lot of people don't believe me that this is actually what's happening when I first tell them this. So I have another example here. So this example, there's a button, and the on-click event handler takes 2 seconds to complete. So let's see what happens. Right? So draw the button down, it stays down until JavaScript is finished executing, and then it comes back up. So you all believe me now, right? Excellent. The key thing to keep in mind is that the UI can't be updated while JavaScript is executing. Right? And that's because the JavaScript that you're executing might cause a UI update. Right? You might do something to the DOM, you might insert something, remove something, change a class, change a style. All of these things are things that the browser needs to know in order to draw the next UI update correctly. So basically, when your JavaScript is running for too long, that means that your UI becomes unresponsive. That means that your user gets upset. So a responsive UI kind of looks like this. Right? Short UI updates, short JavaScript execution, short UI updates. Right? Unresponsive looks like this. Big honking piece of JavaScript in the middle that's doing something that's not allowing the UI updates to happen, that makes the page appear to be frozen. And of course, the longer JavaScript runs, the worse the user experience is going to get. I mean, I'm sure all of us have been on a web page that you just like click and click and click and nothing happens. It's really annoying. The interesting thing is that browsers actually knew that this sort of thing would happen. So every browser, or almost every browser, has a thing called the runaway script timer, which prevents your JavaScript from running for too long, and therefore like freezing the UI for too long. So how many people have ever seen this? Yeah. So this is Internet Explorer telling you that you've reached the limit for how long it wants to let that JavaScript run. And it's waiting too long for that to finish, and it wants you to decide should it continue or not. So for you or I, that's like a minor annoyance. Right? For my mom, if this pops up on her page, what's the first thing she does? Calls me. And then it becomes a major annoyance for me. Don't like it. So this is what IE looks like when it's waiting too long. This is what Firefox looks like when it's waiting too long. Safari when it's waiting too long. Chrome when it's waiting too long. It's an unhappy older guy with a cold apparently because he has a little scar. This is what I look like when I'm waiting too long. It's in Hawaii though, so it's okay. Note the Red Sox. Okay, so what are the limits we're talking about? So Internet Explorer, at least through 8, I haven't had the time to go and check 9 and 10, had a limit of 5 lane statements. Firefox was 10 seconds, 10 seconds of real human time. Safari, 5 seconds. Chrome, I have no idea. It just hooks into the crash control mechanism that Chrome has. And what's funny is I was actually talking to some Chrome engineers, they also have no idea. Okay, just at some random point decides, no more, I'm not going to do it. That's fine. Opera actually has none. So when I was running a benchmark on Opera, I started it, realized that it was taking a little while, went and got lunch and came back and it was still running. Pretty impressive, didn't crash or anything, but you obviously don't want to do that. It's not a good idea. So how long is too long? How many of you have heard this guy, Jacob Nielsen? Oh good, fair amount of you. Yeah, so he's like this usability guy thing, wrote books and stuff, which I now know is not that big of a deal. But he wrote that basically 0.1 seconds is about the limit for having the user feel like the system is reacting instantaneously. That means that if the UI updates within 0.1 seconds, you think, okay, this did something, I'm interacting with the UI. If it's longer than that, then it starts to feel like the UI is dragging a little bit. Like you're not actually in control of what's on the screen. Because if you click and then it's like, ugh, and then it does something, okay, this is weird, I'm not actually using it anymore. I have a little example. Somebody's phone. You should totally get that. I stole this from somebody else's presentation a couple years ago. I'm not going to mention who because it was a couple years ago. They probably don't even remember they did it. But it was a really good demonstration, so I'm going to show it to you. So basically, everybody's getting phone calls. That's awesome. You all are so popular. So each of these buttons has a different delay than the on-click. And it's kind of interesting to see, like, just note to yourself as you go along, at what point do you notice that the button isn't quite behaving the way that you're expecting, right? So this is no delay here. At 50 milliseconds, 100 milliseconds, 200 milliseconds, 500 milliseconds. So where'd you see it? 200. 200? So there's 100, 200. Difference? 500? Yeah. 500 is obvious, right? Yeah. 500 milliseconds. So a few people were grumbling at 200 milliseconds, but it really is like we're talking about milliseconds here. Right? Not seconds, milliseconds. Okay, half a second. But, so what can we take from this? Well, basically, your JavaScript should never run for longer than 100 milliseconds. because you know that while that JavaScript is running, the UI isn't going to be updating, and that means that the user is going to think that the UI is getting a little bit unresponsive. I personally like to say 50 milliseconds should be the limit. Like, anytime I've seen 50 millisecond JavaScript, something really bad is going on there. That's not something you want hanging around. And yeah, I measured an IE6. Because if you're doing 50 milliseconds in Chrome, like, oh my God, what are you doing? There's just no reason for that. Horrible. Does JIT compiling help? Well, basically, you're going from interpretation to compilation. So interpreted JavaScript kind of look like this. Okay? Everything's just a straight shot through. But just-in-time compiling, the first time the JavaScript runs, it stops and compiles and then executes, so that the second time it can just execute because the compiled code is in cache. So is it faster? Yes. Is it 0? No. This still takes time to execute. I mean, I still go to websites that crash in Chrome. You can't imagine what they're doing, but it still happens. So again, it does help, but it's not a replacement for developers being disciplined in how they're writing their code. Right, so we're going to go into load time techniques. How do you get your JavaScript onto the page? Now, some of this stuff you'll have heard of before. Actually, I hope that you'll have heard of it before. But what I want to show you is how it relates to the stuff that I've showed you already in the UI thread. So during page load, JavaScript actually takes more time on the UI thread than it does after. So you never want to do something like this, right? Just like stick your JavaScript right in the middle of the page. Because you end up with something like this, where you have a UI update, so it's drawing the first part of the page, run your JavaScript, and then you do the rest of the page. So the page is like, load, stop, okay, continue on. Really annoying. So this is the example. It would render like hello world, download and execute foo.js, and then render C. What's actually happening in there, in that JavaScript section, it's broken up into 3 parts. So one is download time. Okay, so how long does it actually take to get that resource to the browser so it can do something with it? Second is parse, or maybe compile, depending on the browser. And then third is run, the actual execution. So the kind of pain here is that the download time is completely variable. Right? It might be 0 seconds because it could be in cache. Right? It might be 100 seconds because the JavaScript file happens to be in China right now. You don't really know. And that's problematic because it could load really fast for one person or really slow for another person just because of this download. Right? The actual time to parse or compile and run is constant. That will always be the same. It doesn't matter what happens. It's the downloading that's a huge pain. So the page isn't going to render while JavaScript is downloading when it's just dropped into the page like that. And that's really bad. So you definitely don't want to do anything like this. Right? You have a little JavaScript and then some more, and that is just a really bad idea. Because you have basically stunted rendering at that point. Render a little, stop, do your JavaScript stuff, render a little, stop, do your JavaScript stuff, etc., all the way down the page. Bad stuff. So what do? Put scripts at the bottom. How many people have heard of this? Excellent. So this is fairly old advice. It was first published on the Yahoo Developer Network performance guidelines several years ago now. Put your scripts at the bottom, like that. So what does that do? Well, basically make sure that all of your UI updates happen before you hit that first pause for JavaScript. And that's the real reason that you want your JavaScript at the end of the page. Let all the UI updates happen, then start with the JavaScript download and execution. Because even if the page has to freeze a little bit, at least the user has something to look at. And when we were sticking script tags in head, it would block before rendering would even start, and then you would get a white page for a significant amount of time while that JavaScript was downloading and executing. Really bad user experience. The second thing is to combine JavaScript files. And so you go from 3, where you have this, go down to 1, where you just take one JavaScript task to download, parse, compile, execute. Okay. Much better. That way, you're basically limiting that variable part. Right? We said that the download was the variable part. The more HTTP requests you have, the more variation you're going to have. Every single one of those sort of resets the randomness of how that's going to perform. See, we're just blazing right through these. I know you guys, I can see in your eye. Or it's anticipation of beer. It's one or the other. Not quite sure. So dynamically loading scripts is an interesting technique. How many people have heard of or done this? Okay, 75-ish%. Pretty good. So the basic idea is you create a script node dynamically in the DOM. You assign a source to it. You add it into the page. And then the page starts to pull that in, the browser starts to pull that in, download it. But the interesting thing about doing it this way is that the download becomes non-blocking. Sometimes I'm redundant with my slides. So we had this before, where we had this big download and parse and run. So you can change that. Horrible example, by the way. Use a library. Don't do this at home. Use jQuery. Oh no. What was that? You insert your scripts into the page like this. It behaves a little bit differently. And so we have the first UI update. And then in the background, it actually starts to download. So the UI thread is free to continue doing the rest of the drawing that is scheduled on the page. And once the JavaScript is ready, then it ends up getting parsed / compiled, also in the background. And then finally, when it's ready, it gets executed on the UI thread. So you've basically taken the variable part of getting external JavaScript onto the page. You've moved it into the background so that the UI thread can continue on and do the other things that it has to do to make sure that the page is working the way that it should. Really, really cool technique. And yeah, the UI updates later. So there's a little function that I wrote that's a cross-browser way of doing this. I'm not going to explain it line by line. It's available on the slides, which actually are already on slideshare.net. If you want to go check that out, you can play with this later. Because basically, you just want to be able to do this. So I'd say load script, give it a script name to download, and then have a callback when it's finished loading. Okay, so the thing to keep in mind is that your script will begin to execute as soon as it's ready. So as soon as it's downloaded, parsed, compiled, then it's going to execute immediately, which means it's going to interrupt whatever is happening on the UI thread, kind of inject itself in there. It means that you can't really be sure when that execution is going to happen. You need to keep that in mind. The other thing is that if you're doing multiple of these in a row, you don't necessarily have a guarantee of order of execution among those two. So you need to be a little bit careful. Okay, number 4, deferring scripts. So how many people have heard of the defer attribute for scripts? Okay, about half. Excellent. So defer is actually defined in HTML4. Just remember that thing. That was the one that was actually completely defined and done and just like sitting off to the side. So it's like HTML5, which is like, we're going to change it whenever we want just because it's fun. Yeah. So who supports this? Actually reasonably well supported. The only browser that doesn't support right now is Opera. I heard rumors, hopefully soon. We shall see. So deferred scripts begin to download immediately, but they don't execute until all of the UI updates are done. So basically waits until the end of that first page draw to finish. Basically means as you go along, you get all your UI updates. At some point, it starts to download and parse, compile in the background, and then it holds on to it. So the dynamic script node that I showed you earlier, you'll remember as soon as it was done, it would start to execute then. This will just wait until all of the UI updates are done before it starts to execute a deferred script. So kind of useful. Another timing note, even though the script will execute after the UI updates are done, you don't really know if you have multiple script tags with defer, which is going to execute first, which is going to execute second. It's very, very inconsistent across browsers. It's also kind of inconsistent as to when this will execute in relation to events like DOM content loaded and onload. So if you're going to use this, it's best to use it for just one script, and then use that script to maybe dynamically load other ones afterwards. And then you shouldn't infer any relationship between the time at which this executes and things like DOM content loaded or onload, because that relationship is not strictly defined right now. All right, number 5, async scripts. How do people know about the async attribute? Even less, yeah, like 25%. One of these times I'll get to just like you. That'll be cool. So this is an HTML5 thing. Actually, as of IE 10, reasonably well supported as well. Opera is still the one that's lagging behind. So async scripts basically behave like dynamic scripts, but without you having to write JavaScript. So the download begins immediately as soon as that script tag is encountered. And so we'll download. The UI updates can still happen because the download is happening in the background. Parse and compilation in the background. And then executes as soon as the script is ready. So basically it is the dynamic script node, but without writing JavaScript, just writing HTML. One more UI. I always forget about that last one. And with async scripts, the order of execution is explicitly not preserved. So just like the dynamic scripts, those are going to execute as soon as they're ready. So if the second script that you have finishes downloading and is ready first, then it's actually going to execute before the first one. So nothing to keep in mind that if you're going to be using this, try to use just one, and then use the dynamic script nodes to pull in additional ones after the fact. So how are the load time techniques? Any questions about that stuff?
For the defer tags, you said that they don't execute until the UI updates are done. Should you mean UI updates from the initial page load, not once it gets triggered by JavaScript execute?
Yes. So it basically is like the entire first page paint is finished, and then the JavaScript will execute, and then there may be other UI updates after the fact. Cool. And by the way, you guys should feel free at any point in time to just scream out if you have a question. Well, don't scream, just say hi. Screaming is a little strange.
One question from before that I didn't get a chance to ask you.
Yep.
You said that when you use the JavaScript to load it in after the fact, it runs on that other thread, other than the UI thread. Does that thread have a name?
So it's not actually a thread. It's just basically the network stack. Because the download itself doesn't actually happen on the UI thread, but the UI thread waits for it to finish. So the only thing that's changing is that the download is actually happening over on the network stack, and the UI thread would just be waiting normally. But when you are using dynamic script nodes over for async, then it just doesn't wait for it. It still is happening in the same spot. And I don't know what the actual name, like I want to say it's like the HTTP transport or something like that I'm not entirely sure.
But when it gets parsed and read, does that then take over the UI thread and make it unresponsive? Or none of the parsing gets in the run?
So most of the browsers now actually do like background parsing compilation, so that doesn't block as well. Like I know for sure IE 10 does. Reasonably certain that the latest version of Firefox is doing something similar. As well.
But when it runs, it'll still take over the UI thread?
When it runs, it still happens on the UI thread.
Okay.
So browsers are trying to be a lot smarter about using the multiple cores that we have on processors that are usually not doing anything. Like IE10 has a ton of stuff on cores that are being used.
Are there any performance differences between dynamically loading and using async?
So the question was, is there any performance differences between using the dynamic script nodes and async? They're about the same. No big difference. Cool, okay. Well, I will move on to runtime techniques. And as I said, feel free to just shout out going along with your questions. Runtime JavaScript is kind of interesting. Because for most things, it's really fast. It gets slow when you're doing things multiple times in a row, okay? Like you do in a loop. So this is just a very simple example function. And this is doing pretty much what we all end up doing with arrays, right? You loop over the array, you do something to each item in the array. Like there's no magic here, it's just for conversation. And the fact that you're doing it over an array like that, if that process function is slow and you're doing it 10, 20, 100, 1,000 times, all of a sudden your JavaScript grinds to a halt. And it's not necessarily because you had something that was like, oh my god, slow to start with. It's just the fact that you're doing it so many times in a row. Right, so what can you do for that? One of my favorite techniques is to use timers. How many people have ever used set timeout before? Yeah, it's fun, right?
Evil people thing.
It's magical. Magical. But very misunderstood. So most people that I talk to don't actually understand what set timeout does. Is they think that set timeout says after, like in this case, 500 milliseconds, run this code. That's not what it does. What it says is after 500 milliseconds, create a JavaScript job and stick it into the queue. And so who figured this out first? It was the people who were trying to do animation with JavaScript. Because with animation, you want to know how much time has passed, when you should be doing the next movement of style. And all of a sudden people are like, why is this skipping frames? Like, I was expecting it to run after 50 milliseconds, and it wasn't actually running. This is really weird. And, well, this is why. It's because there was other stuff that was already in the UI queue before this got added in. So what can you do? Well, you can create a function like this. What this basically does, I mean, I'm not going to go through line by line. You can take a look at it online afterwards. Is that it takes an array and starts to process each of the items in the array and times how long it's been running. So it's basically running, it checks to see if it's running for like 50 milliseconds, right, which was my magic number that I told you about earlier. And when it hits 50 milliseconds, then it stops, sets another timeout. This has a delay of 25 milliseconds, which is not magic, it was just a number that I pulled out. And continues on, and it keeps doing that until all of the items have been processed. And when it's done, it calls the callback. And so this basically splits up the processing into little chunks. Now, you don't want to do this all the time, but if you have a bunch of data that needs to be processed, it doesn't have to be processed right away. It doesn't necessarily have to be processed in order, and so you're not dependent on the previous result in order to do the next one. You can split things up really nicely like this and not freeze the UI, because you're giving all these little gaps for UI updates to happen.
But parsing takes also time when you do the set timeout. So parsing that extra code would actually take more time, right?
Then parsing this extra code? Yeah. The amount of time it takes to parse like this code is pretty negligible as compared to the amount of time to execute the same thing over and over and over and over again. So what happens? So let's say you had a button, right, and you were running this function. Click on it. So you have the UI update to draw the button down, right? And a teeny tiny little on click, because basically all it's doing is creating a timeout, which will then wait until later. And then you have the UI update to draw the button up again. And so after 25 milliseconds, you get this JavaScript job that's added into the queue. And assuming that the UI thread is idle, that will get executed. 25 milliseconds later, you'll add the JavaScript job into the UI queue again. And assuming that the UI thread is idle, that gets executed. And so it's these little gaps here that allow for other UI updates if you happen to be interacting with the page. So there's this new technique called script yielding, which I really like. Efficient script yielding is a spec from the W3C Web Performance Working Group. I think it's really cool. Some people don't. I'm always right when there's a difference between me and some people. But basically, set immediate. How many people work with Node.js? Anybody? Oh, a small handful of people. Okay, so for you people, set immediate is basically process.nextTick for the browser. Now you all know that. Yeah, okay. So for everybody else, it's also process.nextTick for the browser, but you'll just have to Google that later on and find out what it is. So basically, set immediate adds code into the queue after all pending UI updates are done. And so it basically waits to see like, oh, is there an opportunity to run this code? Yes, boom, get in there and run that code. And you can use it timeout. You pass in a function. You don't need to pass in a delay because it's trying to do it immediately. Hence the name. Right now, only implemented in IE 10, and it has the vendor prefix, so it's ms set immediate. If you want to play around with it. But basically, this is the exact same function as before, just with set immediate. Nothing terribly exciting there, but I do have an example to show you that is from the IE10 site. So this is basically doing what I've been talking about, which is it's splitting up processing so that the UI can be updated. All of these little green bars here represent values, and this goes through and sorts those values in order. So how many people know what quicksort is? Quicksort, sorting out the row. Yes, wonderful. So this is doing quicksort. What it's doing is it's going through and it's doing one step, and then waiting, like setting a timeout, and then doing another step. So this is with 15 millisecond timers. Should talk about timer resolution quickly. When you say like set timeout 0, it's not actually 0. Right? Because the way that timers work is they resolve to a certain number of milliseconds. So i.e. prior to version 9, the timer resolution was 15 milliseconds, 15.6 milliseconds. And that's actually what a lot of browsers had it at until recently. I think Chrome was the first one actually to change it to like a 4 millisecond timer resolution. So that basically meant if you did set timeout 0 in older browsers, it would actually be like 15 milliseconds. If you did set timeout in newer browsers, set timeout 0 in newer browsers, it would end up being about 4 milliseconds or so. And so that's actually a pretty dramatic difference when you're trying to split up a bunch of processing. And so this is, Microsoft does this weird thing where they call like everything before IE9 is like HTML4. There's no such thing as like HTML4 timers. And that's just like crap they made up. So run this test. You see, it starts to move along. Right. It's a little bit washed out there, but you can see things start to move around. So it's actually sorting the data and then updating the UI to represent the new state of the data. And it can only do that because it's using set timeout so that there are those little gaps so the UI can actually update in between each of those little sorts. Right, it's going along. And there's people in the back right now thinking, is he going to make us wait until it actually sorts all the way through? I'm thinking, well, it's pretty close. I talked through most of it. So, we're almost there. Mom always told me, finish what you start. So, there it is. It's done. And then, how long did that take? Well, it took 47 seconds. The last 15 of that was, of course, painful. Sitting here watching for that. Power consumption, standard, CPU efficiency low. These are just things that they threw in there. It wasn't actually measuring any of that stuff. It's like, I'm just telling you that the CPU efficiency is incredibly low. Trust me on that. So the HTML5 timers, there's also not an HTML5 timer. This is just 4 milliseconds, so it's faster. All right, and we'll see what happens to that. So you can see it's faster, right? Not nearly as much dread in the room as for this to finish. And so that was pretty good. And the power consumption was high, according to the static HTML that's in the page. CPU efficiency is a little bit better. I can tell that because low is red, and medium is orange. I compare that with set immediate, right? Right? So I actually allocated a little bit more time for this example, so we're just going to do that a few more times. Just for fun. And you can see the CPU efficiency is high, clearly. Power consumption, low. Nice. You see the difference in how long it takes to complete this, right? So 47 seconds, 9 seconds, less than a second. It's pretty, yeah.
So what does UI response look like between the 3 sorts while sorting? Like, is it, if you were to put some other button somewhere, I don't know, have it do something when you click it? will that secondary thing be perform better with the 50 milliseconds because you're yielding more time to do other things while it's, you know what I'm trying to say?
Yeah, so it depends on how long your process is running. Right? Because if you want to get the process done as quickly as possible and you use like set immediate or a set timeout with 4 milliseconds, then you're not going to have as much time for that thing to happen. It will sneak in there. It will actually get in the middle because it's all just getting added into the queue, so it gets executed in the order in which it happened to be in there. But if you expect that the user is actually going to be doing a bunch of things on the page while you're doing that processing, then yeah, you want to use a larger delay for your set timeout to leave more time. I used to do an example back before browsers got so fast. That was really good, and now it's just like so fast that it's a completely crappy example to show, so I don't show it anymore. But people used to actually say, because I would put in like a 25 millisecond delay and start doing things, and you could actually see still like a little delay because there were other things that were going on. So, you know, if you're sure the users are actually going to try to be doing stuff while you're processing, then you want to increase that delay, maybe even to like 50 milliseconds, depending on how quickly you need to get the processing done.
If you were to use a for loop to go through this, like roughly how long would it take?
If you're using a for loop, it would take, say, it would take less than the 500 milliseconds that are down there.
It would be non-responsive the whole time.
Yeah, it would be unresponsive the whole time. And my guess is that you would probably end up getting to around like 100 milliseconds or so. Because the UI update also takes a non-trivial amount of time in order to like move stuff around. But just try it out, see what happens. Report back, tweet it to everybody. Okay, so you know what's really cool about this? I noticed this actually after the last time I gave this talk. I did this example. Shows you what a geek I am, right? I immediately went for the buttons and started playing with the buttons. I didn't read the stuff that was underneath there. And so it says, web developers commonly use the set timeout API to break apart long-running JavaScript operations. So cool. Well, let's see where that was. Oh no, I'm on the wireless. So it links to nowhere, and that ruins my story.
You can show the hover.
Moving on.
It shows the URL.
The URL doesn't tell you.
I assumed it referenced you.
It referenced me. Which I didn't realize at first, even when I clicked through, because I read it, I'm like, oh, like, who's this guy that wrote this thing about script? Like, that's in my book. What? That guy's totally like stomping on my territory, right? And it turned out that it was actually the like O'Reilly blog, and it was the guy who was posting a sample snippet from my book. I'm like, oh, wow, I feel like an ass. Anyway, so set immediate worked the same way as set timeout, pretty much. So UI update, small on click because we're just setting up the set immediate UI update, and then after the last UI update is done, right? So once the queue is empty, the next JavaScript task goes in, and so on. Keep going, keep going. Okay. So again, very similar, just a lot faster, so get stuff done faster. Don't know if it'll make it into other browsers. I've been talking with people, they're like, well, Microsoft's really the only one that likes it. We'll see, but I like it too. And that, and you know, $2 will get you a copy. So the third thing you can do is use web workers. So how many people have heard of web workers? Wow, a lot. The word's getting out. That's awesome. So web workers went too fast. It's a separate spec. It's very interesting because basically is the idea of creating threads in JavaScript, but maybe not threads. So let's learn a little bit more about that. Pretty well supported now that they've been added into IE 10. That's really cool. What are they? So asynchronous JavaScript execution. So the JavaScript that's happening inside of the worker doesn't block the UI thread. It's literally happening in the background. And it's a completely data-driven API. And so you pass data in and you get data back out. You have no access to the DOM or the BOM. And it's a completely separate execution environment. Let's see, is there one more bullet there? No. Okay. It's always hard when you have a bunch of bullets popping up. What's really interesting about this spec is it doesn't say how web workers should be implemented. It basically says they can be implemented any way you want. So you can implement it as an actual thread if you want to. You can implement it as a separate process that's going on a separate core if you want to. Opera actually is single-threaded, and they do kind of an interesting interweaving, like round-robin type of thing with this. So it's not actually happening in the background, but it appears to be. It's kind of cool. This is the appears to be sign. I know, it's getting late. Bear with me, we're almost there. So this is how you use a web worker. At the top, this is in the page. So you say new worker, pass in the URL of a JavaScript file that has the code to run inside of the worker. You pass data into the worker by saying worker.postMessage and giving it data. So that's any string data or structured data. Basically anything that you would serialize into JSON, you can pass into this. And then you get information from the worker by listening for onMessage. And that returns to you data on event.data. And then you can do whatever you want with that data. Inside of the worker, you hear from the page by also listening to onMessage. So when onMessage gets called inside of the worker, that means the page called postMessage to you. And now you can go and do something. So in this case, I'm just going through and processing each of the items in the array, and then posting the array back up. So the post message down here goes back into the page, just passing data back and forth. And so what happens? Well, if you had a button that was running this, click it, draw the button down, have a UI update, run onClick, and then the worker thread gets created, or the worker process, or whatever. The JavaScript is executed while UI updates are happening still. It's happening in the background. And then when the worker thread is complete, it creates this onMessage job in the UI queue. And as soon as it's ready, that gets executed. And this is a little misleading because the worker actually stays around after you use it. It doesn't just go away until you manually destroy it. But really, really cool. So what questions do you have about that before I move on to the last section?
Browser support?
Browser support. Boom, 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 boom. Boom, 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 boom. Yeah, it's painful, right? But all to get to a pretty graphic.
What about mobile support?
Mobile support added in iOS 5. Android does not have it.
Does it hang after 5 or 10 seconds?
Can you say that again?
Does the request hang does it pop some message that it takes too much time to execute?
Will the worker pop up a time that says it takes too much time to execute? Actually, yes. So I discovered that on an accident on a project. That I haven't actually timed it yet, but it will eventually stop you. So if you just create a worker that has a loop in it and just leave it running, eventually you'll get the same dialogue from the browser. Yep.
Semi-unrelated question, but you mentioned that Opera single-threaded.
Yes.
Why?
I do not know.
Fair enough.
But there are plenty.
Does that seem like bad?
Honestly, well, I'd say this. I've never built a browser before, so I don't know if it's a bad idea or not. But having built software, I know that there are plenty of design decisions that I've made personally that people have come back afterwards and been like, that seems like a really bad idea. Not to say that I always make the right decision. Just almost always make the right decision. But without understanding all of the things that they knew and they had to support that led them to that decision, I can't even venture a guess at whether it's good or bad or intermediate. It's certainly different. But like I said earlier, they do some pretty interesting things because the browser won't hang even if you continue to run JavaScript. So in theory, this shouldn't be possible with a single thread, but yet they figure out some way to do it. So by the way, the Opera folks are pretty vocal, so if you find any of them on like Twitter, on blogs, and ask that question, they'll probably tell you exactly what that is. I encourage you to do that. All right, now I have to go all the way through. Okay. So, last section, almost there. I want to talk about Repaint and reflow, which are two UI operations that happen in the browser. And the reason we care about this is because long UI updates also lead to an unresponsive UI. It just makes sense. Like you said before, if JavaScript is taking a long time on the UI thread, then the UI becomes unresponsive. Also, if the UI updates themselves are taking a long time, the UI can also become unresponsive. So JavaScript is fun and interesting because it can actually trigger UI updates, like we talked about earlier. And it can trigger both Repaint and reflow. So Repaint isn't all that bad. It basically happens when you change something on the page, but it doesn't actually change the layout. Right? So you change the color, change the background color. You set the visibility of something to a different value. Nothing on the page moves, but yet something is different. That is a repaint. So change color here. Okay. Reflow is a little bit more expensive. Because reflow is what happens when you need to recalculate all of the boxes on the page to make sure that they're laid out correctly. So that happens when you do things like change width, change font size, change height. All of these things start to move rectangles around on the page. And that means the browser has to stop, recalculate where everything should go, and then continue on. And so adding an element into a page, you're going to trigger a reflow. It needs to make sure that everything is being drawn in the right place. And these basically get queued up as the JavaScript is executed. Right? So as you go through, like this loop is basically creating 10 items, and that means there's going to be 10 reflows. Like those are being queued up as the script goes along to then be executed as soon as the script is done. And so limiting your repaints and reflows actually improves your overall UI performance. So the first thing you can do is perform your DOM manipulations off of the document. So these are pretty fast because you're not triggering any repaint or reflow. It's basically happening invisibly behind the scenes. And there's a few things you can do. One thing is you can remove an element from the page, make all of your changes, and then add it back in. So you basically are triggering 2 reflows there instead of potentially a bunch. Set the elements display to none, make your changes, and then set the display back to the default.
Well, hiding an element sometimes itself trigger a reflow, because if it's like a block that's in text and then it'll, or blocking something, a bunch of other things, and make this appear, and we'll try to switch back to get, is that not a reflow?
It is.
Okay.
Yeah, so you basically, the trade-off that you're making here is 2 reflows for potentially more.
Oh, I was just saying in general, you had mentioned that it only causes a repaint, but it actually does cause reflow.
It causes a reflow.
Yeah.
Yeah, if you set the visibility to hidden, it's
Yeah.
just a repaint. But if you set the display to none, then it's a reflow.
Right.
Yep.
Oh, I see.
Is there an issue with measuring elements, like
Yeah.
getting the width if you pull them off the DOM, if they've already been on it, or?
Yes, there is. I'm going to get to that in a second. So the other thing you can do is build up changes on a document fragment and then apply them all at once. I'm going to talk about document fragment because it's usually the one people haven't heard of. How many people have heard of document fragment? Okay, it's about half. It's pretty good. So it's kind of an interesting thing. It's a document-like object that has no visual representation at all in your page. It's just a helper class that's basically just hanging out there to do work for you. It's considered to be owned by the document from which it was created. The really interesting thing is if you pass a document fragment into append child, instead of appending the document fragment to that, it takes all of the document fragment's children and appends all of those. So here I rewrote this example going through and creating these 10 items. Instead of adding them directly to the list, I'm adding them to a fragment. So you create it with document.create document fragment. So fragment.append child. So adding everything onto the fragment first, which again, because it has no UI associated with it, you can do whatever you want to it, and it's not going to trigger repaint or reflow. And then at the end, say list.append child fragment, and that adds all of the children that were on the fragment onto the list. And so you end up with just one reflow instead of 10.
Is that technique comparable to creating a node as like a jQuery set and
These guys are nodding yes, so
Okay.
I think the answer is yes.
They use it direct.
okay, yeah, so this is the raw JavaScript way of doing essentially the same thing.
It's exactly, they're using
okay.
fragments in back.
Yeah, it's true. And the way that I learned this is I gave this talk first at the jQuery conference last year, and Yehuda was sitting like right there, and he said, "We do that in jQuery." I was like, "Okay, cool." Number 2, group style changes. So you never want to do something like this. Right? This is really bad. Because you have like repaint, and reflow, and reflow, and then repaint. Bad, right? Don't want to do. There's no reason to do that. So there's a couple things that you can do. One is you can group all of these into a class, right? And then just change the class on the element, and then you end up with just one reflow. So there, of course, there is a little bit of overhead with that to calculate the cascade for the class, but it's still better than doing this individual like style dot whatever assignments. You can also do style.css text and just actually put all your CSS text in there. Works as well. So the third one is to watch out for accidental reflow. So this is what you were talking about. What can happen is you can go in and set the width of something or the height of something or so on, and then try to read that back. That's actually going to cause a reflow in the middle of your JavaScript. And so in this case, I'm setting the width to 100 pixels, and then I'm reading offset width. Now offset width is a calculated value, and that means that the browser has to stop, apply all of the changes that were queued up to that point, and then return that value to you. Which makes sense, because if that previously was 200 and it didn't go through and apply the other change, you would read back offset width and it would be. So the browser has to stop at that point, go through all of the reflow, and then restart your JavaScript. And you want to avoid that as much as possible, because again, you're blocking the UI thread at that point.
How about client width in conjunction?
All of that stuff.
Client width is the same as offset width.
Yep. So basically, any value that is computed. And so that's all of the offsets, all of the scrolls, clients. If you do get computed style or current style in old IE, all of those things will trigger reflow in your JavaScript because it wants to return to you the correct value. The only way it can do that is by applying all of the changes to it.
When are things queued up as opposed to happening immediately?
So the UI changes are queued up as JavaScript is running, and then they happen immediately when JavaScript is done. They all just go
Okay, so
one
bar
after the other.
calculated field, they don't wait till the that JavaScript block is.
Yeah, reflow. The natural thing that reflow does is wait for JavaScript to finish before it happens.
And it'll have to do that even if there are no updates being made because it doesn't know, right?
Yeah. So and there's stuff. If there's nothing that's been queued up, then it will just return whatever was the last.
But like, there's still script executing. Maybe it doesn't have any updates that would cause reflow, but it still has to wait for all the script to finish.
Yeah, for the chance for there to be one. Yep.
Question?
Yes.
Does an absolutely position down element versus a relatively position down element have any difference in?
Good question. So absolutely positioned element versus relatively positioned element. Depends on what you're doing with it.
I mean, specifically when you're calculating offset width or when you're moving it around, specifically moving it around.
So if you're moving it around, then it's still going to end up triggering a reflow to figure out the right stuff, because there's a bunch of other things. I can tell it's getting late in the night. I'm using words like things and stuff. I'm trying to explain concepts. I'll just go with it. Because there are still other things that may be affected by moving that around. That's horrible. I'm sorry.
Do you happen to know if using CSS3 translate has the same impact, or is that one way to minimize?
If CSS3 translate is used, so translate I believe will just cause a repaint. I don't think it causes. I don't think it causes any layout changes.
Is there any way to measure how many repaints and reflows your thing's doing, like just like a debugger?
Yeah. Any way to measure repaint and reflow? There is. So Chrome has in the developer tools a panel called timeline, which actually shows you like when things are painted and when like JavaScript is executing, when it's doing all kinds of interesting things. There's also this tool called Dynatrace that will do the same for Internet Explorer and Firefox now.
There's also, you can start Chrome with a paintrex flag, and it'll show you all the paint rectangles on the screen.
Oh, yeah, is that a WebKit flag? Because I think that works on Safari as well.
I saw it, like, I think Mars did it.
Yeah. All kinds of cool stuff with WebKit. So does hardware acceleration help? Well, traditional rendering, what's happening is you're doing basically all of this calculation, right, the compositing, and then drawing, and that's all happening on the UI thread. So it can take long. So hardware acceleration, the UI thread basically hands off all that stuff to the GPU, and then waits for the GPU to finish, and then continues on. So again, just like the JavaScript, things go fast, or faster, but it's not 0 time. It still takes some time in order to work. So don't use this as you're like, well, it's GPU accelerated, it's fine. Yeah, so right to the end, just to review the things that we talked about. If you leave here not having learned anything else, I hope that you'll leave with an understanding of the UI thread and how it can affect the page performance in terms of your JavaScript and the UI and responsive. So responsive UI looks like this. Right? Unresponsive UI can look like this, JavaScript taking too long. And it can also look like this with your UI updates taking too long. And a few different ways to avoid slow loading JavaScript. Right? Dynamically created scripts, deferred scripts, and async scripts. And you can avoid your slow running JavaScript. Remember, 50 milliseconds is the time that I like to keep in mind. Everything should run in less than 50 milliseconds. You can break up long JavaScript processes so they don't freeze the UI with timers, script yielding in the future, web workers now. So don't be horrible. You be awesome. That is it. So you can grab these slides up on SlideShare, slideshare.net/nvids. So is there questions? Yes. Do you guys have any other questions?
I think not a question, but another way to speed up that thing that you're doing with timeouts is run it by batches, like 4 at a time or 8 at a time, which is also.
Yeah. So that was what the first function that I showed did. So it basically ran through until it hit 50 milliseconds, and then stopped. Did its set timeout, and when it picked up again, did as many as it could within 50 milliseconds, and keep going like that.
I thought you ran it only once at a time.
What's that?
I thought you only ran like the function once every time out.
So that was the IE example that ran it once every time, but my example, which is vastly superior. I actually did a bunch and then pause after it reached 50 milliseconds and continue on after that.
And I had another question. Do you happen to know, it's like a mystery why backward looping seems to be faster in general? Just now it's not that much faster, but before it was a lot faster.
So I actually do not believe that backwards looping is faster. what I've seen, I did a bunch of benchmarks on this. I actually wrote about it in a high-performance JavaScript. Is what I found when I was looking at other people's benchmarks was it wasn't actually going through the loop backwards that was faster. It was how they had set up the loop, like the structure of the loop itself, that made it faster or slower. Because incrementing and decrementing, same amount of time.
Exactly.
It's not magic. And then you're still comparing at the end a value to another value, which is still the same. So that old backwards loops being faster, not true.
Really? That was true in my testing that I did.
It's probably the way that you were setting up
Maybe.
the loops.
Maybe the memory. Yeah.
Because what I found in a lot of people's ones was that they actually, when they were doing backwards looping, the control condition was slightly different than when they were doing forwards looping, such that the control condition actually took a little bit more time. I can't remember what it was exactly.
They were comparing against 0 versus comparing against the length. And if you compare against the length, this actually takes up 2 operations, something where 0 is 1 operation.
That sounds very familiar. Ben, was that what you were going to say?
Well, that's
too?
what I was going to say. Like when you're doing a backwards loop, you'll initialize your counter to the length and decrement it until it like hits 0. But when you're doing a forwards loop, a lot of time you'll actually compare against the length every time to see if you've hit it. If you were to set a variable, var len equals whatever dot length, and compare against len, it would probably be the same.
No, I made sure that that case was covered, so I actually knew about that. So, so I have no expression. So it might be that the memory usage, but obviously we can.
So
take
what
it
I
to
would encourage you to do is, are you familiar with JS perf?
Yes, I use that to compare actually.
Cool. So tweet at me the URL for your test. I'll take a look at it. I live for benchmarking. Yep.
So when the browser's doing a reflow, how much effect does the complexity of your CSS have on how long that takes?
Excellent question. So when the browser does a reflow, how does the complexity of your CSS factor into that? It definitely does. And the way that it factors in is more with the cascade than anything else. Because just if you have, a div on the page and you start messing with that div, it's not that big of a deal because it's living out there by itself. It's not doing anything that's affecting any other elements on the page. But as soon as you start adding other elements on the page, as soon as you have classes applied throughout that it needs to calculate at each level going down, 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 that's when it starts to add up. So I like my usual recommendation for CSS is you should try to keep your selectors as simple as possible to make sure that you don't end up with these like massive cascade trees that just take a ton of time to figure out. Guys have any other questions? Yeah.
You showed one optimization technique, which was to combine multiple JavaScript files into a single download. There's a counter benefit of if that same, if bar and baz are used on other pages, they can be cached. So I know there's a benefit there. My question is there any performance difference in when the page compiles, when the browser compiles that JavaScript, if they're in one file versus two, ignoring the download part?
Yeah, because it basically, every file is treated as atomic. It's just like the way, the way that the browser cache works, is that whatever is in that URL, that's basically the key for that file in the browser cache. And the same is true for compilation. Is that if it's in the browser cache, and you're in the same session in which you compiled that file before, then it will have it pre-compiled for you. But if you close it and come back later, then it's not. It might be in the browser cache, but it might not be in the compiled cache anymore.
So if foo and bar are in my download cache, and I reboot my computer and I come back, and it doesn't have to load them from the network, is it faster if they were combined into one file to recompile them, or is it just as fast if there are two files?
If it's already in the browser cache, it's trivial, the difference between the two. Do you guys have other questions?
Do you know what modern limits are on the number of held requests?
Modern limits on the number?
Because I know like IE6 used to be like 2, and then it went up to like 4 or 6 or whatever, but I don't know, I haven't heard lately.
Good question. Off the top of my head,
browser scope has all that stuff.
Yeah,
Browser scope.org.
this is true. I'd say that it sounds about right. But memory is failing.
Do you have any exciting thoughts about request animation frame?
Do I have any exciting thoughts about request animation frame?
Yeah, like maybe it's similar to set immediate.
So I have some thoughts. I'm not sure if they're exciting or not. Yeah, so what's interesting is I wrote a blog post both on, on my blog up there, both on set immediate and also on request animation frame. And there was some like cross-pollination between those two in terms of comments. And basically, are you guys familiar with request animation frame? Many people? Okay. Oh, okay. So request animation frame is a function that is also defined in the spec that's written by the W3C Web Performance Group, which is basically, the goal is to tell the browser that JavaScript is doing animation, so optimize appropriately. And literally request animation frame tells the browser, hey, I'm doing an animation, I want you to do a paint. Here's a function that I want you to run before you do a paint. So that you actually get much smoother animations that way because you're not using timers anymore in order to do your animations. You're actually just scheduling UI updates with the browser directly, which is really cool. So that versus set immediate, they're kind of doing similar things, but at different points in time. And so request animation frame you call, it says, please do a UI update, and right before you do that UI update, run this JavaScript. And set immediate says, when you do a UI update, immediately after, run this code. And so could you use request animation frame to speed things up? Yeah. It would be a little wonky, but it would probably work. Whether it's efficient or not, we'll have to wait for Microsoft to create a page with static. Tell us. Yep.
So minification obviously reduces file size, which will reduce the download. Is that, are there any different, I know there's different kinds, do they have any effect on the parsing?
Oh, interesting question. So does minification have effect on the parsing at all? I can tell you that minification speeds up the parsing, just obviously because there are less characters to go through. But it turns out that JavaScript engines are really, really fast at parsing now. So the difference is really, really small. In bygone days, there's actually a difference that you could measure, but it's almost completely gone at this point.
Aren't we sort of back to that with some of the mobile devices? I've heard that parsing can take a while on some of the current mobile platforms.
Yes. So mobile, everything is slower, just across the board. Rendering, JavaScript execution, disk access is really bad. Using like local storage on iPhones and stuff, it's kind of slow. So be careful when you do that. Yep.
Do you recommend any frameworks when you're considering performance and things like that?
Do I recommend any frameworks when I'm considering performance?
Probably not.
No.
Something like Clojure or something like that?
Yeah, so for JavaScript minification, I use my UI compressor. Partly because I worked at Yahoo, partly because I know the guy who wrote it, and partly because I'm scared out of my mind of what Clojure might do to my code. I know it's fine for some people, but understanding what it's actually doing, like I have way more understanding of what it's actually doing than I ever want to. It's kind of like if you've ever had surgery, you don't actually want to know what's going on. You just go to sleep and wake up and just deal with it, right? And so like I had surgery a couple of years ago, and I remember I woke up and I was like, oh, crap. if they had told me this, I feel like this, I don't know what I've done. And then I was like watching some TV show about like what they actually did. I was like, oh my god, like I let somebody do that to me? That's insane. Like why would anybody do that? That's kind of how I feel about closure components.
So what do you do about like cross-browser problems then? Maybe you hand code it yourself then?
Cross-browser problems in terms of what? Give me an example.
Then doing things differently.
So in terms of like a JavaScript like abstraction, I usually recommend YUI because that's what I know. It's what I've built a great many things on. YUI 3, YUI 2. And depending, I actually do recommend jQuery, and depending on what people are building. Because I'll be the first one to tell you, I don't know jQuery that well. I have used it, I've built stuff with it, understand it pretty well. I'm not the guy to go to for like, what's the best way to do it in jQuery? That would be Ben. Like, those are the only two that I've used and actually felt like I could do things in such a way that it would end up well. Other ones I've not had so much luck with.
There's a pretty cool new minifier. It's called the shrinker.ch. I don't know if anybody heard about it. You should check it out. It's a little compressing a little better than YUI. Sorry, no offense, but
it's fun.
It's a couple percent. It's only a couple percent though. But
yeah, there's also Uglify.js. That's also a new one that popped up in the past year or so.
I guess one quick follow-up to the minify question. So do you think there's any room for optimization there, or was it kind of a waste? I remember reading an article about like, you know, when you minify, you drop your variables to single letters, and if you avoid the use of letters that begin keywords, then it doesn't have to like figure out if you're going to use a keyword, so it's actually a little faster. And there's like 19 letters or 11 letters or something like that you can actually use for that, but I don't know if it's worth even looking into.
Yeah, I don't think so. Yeah, I think that once you get to the point of replacing variables, like local variables and local function names, with single character or double character, I think your job is done. Like, going any further than that seems like, you know, an interesting academic exercise, but I'm not sure how much more benefit you get after that point.
So unless you're like competitive package.
Yeah, I mean, you know, large companies hire, you know, researchers and academics to like do this sort of thing. That's how Dart came about. You basically just get a bunch of people in a room and say, come up with something, like do something interesting, and then tell us what it is when it's done. It was actually a really cool part about working at a big company. I get to do that sort of stuff. But at some point, it crosses over from being practical into more theoretical and academic, and that's the point where I go, okay, I'm out. So there's somebody over here. Yep.
You wrote a blog post a couple years ago about the use of data URIs as opposed to CSS sprites.
I did, in fact, write a blog post about data URIs a couple years ago.
I was wondering if your thoughts on that have changed in the last couple of years.
I love data URIs. I do. If I were the type to get a tattoo, I'd probably.
So your thoughts haven't changed. So it's still.
Yeah, I'm similar with that. I really like data URIs for a bunch of reasons. Not the least of which is actually for these.
Yeah.
Because as it turns out, there's this interesting, and I always get into discussions with people about this, where some people are like, well, yeah, you know, if you concatenate everything, bless you, into one file, well, then you're losing like the parallel downloads of like multiple JavaScript files, right? Which is true. So you just have one HTTP request that's downloading everything, and so will it take longer if it's large versus doing a bunch of ones in parallel? Probably. But there's an interesting tipping point in there somewhere. Right? Is that parallel downloads only help you when you have low latency, high bandwidth connections. And so if I'm plugged into the wall, parallel downloads are way better than a single large download. It turns out on high latency, low bandwidth connections, one single large download is better than multiple parallel ones because there's a constant amount of overhead for each HTTP request. And that will actually end up taking longer. So if you ever go to India, for example, where high-speed internet is not ubiquitous, and then try to access a site back on the US, start to see this. So when I worked on the Yahoo homepage, we launched initially in 4 markets, so US, UK, France, and India. And where we got the most performance complaints was from India, which made sense because everybody's on a slower connection. And so the first thing that we did was started trying to combine more of the files, and that ended up speeding up their experience more than it was slowing down other people's experience. So there's a balancing point in the middle of those two that is kind of interesting depending on what you're targeting. If you're targeting mobile, then getting everything into as few requests as possible is really key because the overhead is just horrible. And that's why I love data URIs for mobile. Just embedding the images inside of the CSS so you're getting all of that just in one download instead of multiple HTTP requests. That was a much longer answer to that question than I anticipated.
That was a good explanation. But I have another question. What are your thoughts about modular approach to JavaScript? So basically, because we have our own framework, we don't use any of the popular frameworks. And it got to the point where our library became pretty big. And we ended up comparing a lot of these approaches, some of the approaches that you went through. And we ended up going with basically breaking it up and then combining it in compile time and including it in the DOM. So, I mean, what are your thoughts about this versus having separate JavaScript files?
So the question was about having a bunch of like JavaScript modules and then combining at compile time into one thing. I love that, quite frankly. Like YUI basically allows you to do that not at compile time but at runtime, so page load time. So you can basically say, hey, I need these things on the page, and it will create a URL and download all of that stuff for you in one request instead of multiple ones. And I do think that that usually is the best way to go because creating these like monolithic JavaScript libraries like we used to 5 years ago just doesn't get the job done anymore. There's too much need to mix and match them. So I'm a big fan of modular JavaScript. I actually have a whole separate talk on that. I'm not going to do it tonight. It's up on SlideShare as well.
That's sort of a follow-up data URI question. So we use a lot of them, and we see in our logs a lot of requests for the data URIs as if it was like a relative path. And I was wondering if you've ever seen that in your logs.
So requests for data URIs coming in. Internet Explorer, I know, has some quirks with data URIs that can cause that. Are you using them with like web fonts?
No, just
regular URIs. Yeah. Because I know, I think IE even up through 8 had some trouble properly parsing data URIs. And so I know sometimes it could end up trying to make a request back to the server. But the only example that anybody ever showed me of that happening like in front of my face was with a web font.
Okay.
So I'm not sure about the other ones, but it has something to do with having the like URL data colon like maybe something else in there.
Yeah, so we looked at the user agents, and it comes from a bunch of different user agents. And so one of our hypotheses is that it could be virus catchers because you can use data URIs to do XSS attacks. And so one hypothesis we have is that it could be like a virus program trying to scan them for XSS content.
Interesting.
But anyway. All right, maybe we should wrap up, and then if you have more questions, you can stick around and handle those afterwards. So let's thank Nicholas one more time.